Superchargers and turbos are both used to increase the power output of an internal combustion engine by forcing more air into the combustion chamber, allowing for more fuel to be burned and thus generating more power. However, they achieve this in slightly different ways. Superchargers. A supercharger is a mechanical device that is driven by the engine itself, usually through a belt connected to the engine's crankshaft. It forces more air into the engine's intake manifold by using a compressor that compresses the incoming air. The compressed air is then delivered to the combustion chambers at a higher pressure, allowing for more fuel to be added and burned efficiently, resulting in increased power output. There are two main types of superchargers: positive displacement and centrifugal. Positive displacement superchargers. These superchargers deliver a fixed amount of air with each revolution. They provide immediate and consistent boost throughout the RPM range, making them effective for low-end torque and quick throttle response. Centrifugal superchargers. These work more like a turbocharger in terms of how they build up boost. They are driven by a belt connected to the engine's crankshaft and use a rotating impeller to draw in and compress air. They become more efficient at higher RPMs, making them suitable for engines that operate in a higher RPM range. Turbos. A turbocharger, often simply referred to as a turbo, is a device that utilizes the exhaust gases produced by the engine to drive a turbine, which in turn drives a compressor that forces air into the intake manifold. Here's how it works. Exhaust gas energy. As the engine burns fuel in the combustion chamber, it produces exhaust gases that contain energy. These gases are directed through the exhaust manifold and then pass through the turbine of the turbocharger. Turbine. The exhaust gases flow over the turbine blades, causing the turbine to spin rapidly. This spinning is what drives the other side of the turbocharger. Compressor. Connected to the same shaft as the turbine, the compressor draws in ambient air and compresses it before delivering it to the engine's intake manifold. This compressed air is denser, allowing for more fuel to be added and burned, resulting in increased power output. The key difference between a supercharger and a turbo is their source of power. A supercharger is directly connected to the engine and is driven by the engine's mechanical power, while a turbocharger uses the energy from the engine's exhaust gases to drive its turbine. Both superchargers and turbos have their advantages and disadvantages, and the choice between them depends on factors like engine design, desired power characteristics, packaging constraints, and efficiency considerations.